Hi, it's Mr. Anderson, and this is AP Physics Essentials, video 68. It's on the angular momentum of a system. Now, if you give a top rotation, it's going to start to pick up angular momentum. You just remember, using the right hand rule, you can put your fingers in the direction of the rotation, and it's going to have angular momentum perpendicular to that. Now, if you notice a top as it spins, it's starting to pick up this wobble. We call it precession in physics, and it's going to get bigger and bigger and bigger, and eventually that top is going to come to a standstill. And the reason why is there's not just one angular momentum acting on that top. And so if we look at it, it's rotating in this direction, so it'd have the angular momentum in this direction, but there's another force, therefore another torque acting on the top. That's going to be the force due to gravity, and it's acting in this direction. So again, using the right hand rule, we're going to have a force coming right at us, and that's causing this precession up here, or this wobbling of the top. Our Earth experiences this same thing. So it's rotating, but as it rotates, it's going to slowly do this big wobble. Now, it takes 26,000 years for it to do that wobble, and it's not a top, so it's not sitting on a table, so there can't be a force of gravity acting on it. But there are other objects like the sun, the moon, and even other planets that are tugging on that, applying a force to it, and that's why it's getting this precession. And so if a system has objects inside it that are in motion, it's going to have angular momentum. And to figure out the angular momentum of the entire system, all you have to do is figure out the angular momentum of all the objects inside that system. Now, those could be point objects, like a ball revolving around a string. To figure out the angular momentum of that, remember, all you do is take the radius, or the distance from the center to the object, and then you multiply that times the individual momentum of that object. In other words, its mass times its velocity. If it's an extended object like this, to figure out its angular momentum, all you do is multiply its rotational inertia times its angular velocity. And so if we have a system like a helicopter, and that blade on the top is rotating, as it rotates, we're going to have angular momentum. Now, the angular momentum in this case would be pointed up. Now, what's going to happen to that helicopter if we only have one blade on it? As it exerts a force on the air, the force is exerting a force back on it, and so the bottom part of the helicopter is going to start to rotate as well and be out of control. And so what they do is add another object to the system. You have a tail rotor, and that tail rotor, as it spins, is applying another angular momentum, and so we can use that to keep our helicopter stable. Now, to calculate the angular momentum of a point object, all you do is take an object that's revolving around a center, and you're going to multiply the radius times the momentum of that object. And so the momentum of the object, remember, is going to be the mass times the linear velocity of that object. Then we simply multiply it times the radius, or the distance from the middle. Now, in which direction is that angular momentum? We use the right hand rule. And so as I move my hand in the direction of the object, we're going to have angular momentum that's going to be pointed up. If we're looking at an extended object like this, all we do is multiply the rotational inertia times the angular velocity. In other words, how fast it's spinning. Now, in which direction is that angular momentum acting? As I move my fingers around, it's going to be acted in the up direction on that extended spinning object. Now, a great way to study this is using a gyroscope. And so this is a video from MIT. There's a longer video description of this. I'll put it down below, but I'm getting kind of to the highlights of it. And so what they've done is taken a gyroscope, they've spun it up. It has a huge amount of mass, therefore a huge amount of rotational inertia. And so it's spinning. You can see the direction of spin right here. And so as it spins in that direction, what they're going to do is they're going to apply a force. So they're going to apply another momentum on the other side of it, or a torque on one side of it. And so you got to try to figure out what's going to happen to that gyroscope as it does it. And so as I use my right hand rule of the gyroscope itself, what we're going to get is there's going to be angular momentum pointed out in this direction. And so what they're doing is adding another force. So they're going to add angular momentum to it. And so they're going to add a force in this direction. And so to figure out which direction that's going to go, you have to use your right hand rule as well. And so what I'm going to do is, again, it's centered on this point, and they're applying a force in that direction. So I'm kind of moving my hand like this, and what should happen is there should be a force towards me. And so as I let this go, you can see that as they push up, it actually turns in a non-intuitive direction. It's moving in a direction that really doesn't make sense unless you understand that this is an entire system, and that entire system is made up of the angular momentum of all the objects. Now you try. So now it's spun up again, and what they're going to do is point down. And so try to use your right hand rule to figure out what's going to happen to that gyroscope. And now let me play it. And so you should have predicted, since you were pushing down on it, there's going to be an angular momentum that's pointed away from you. And so it's going to move in that direction. Now it really takes that right hand and figuring out where you are in relation. So again, we're doing the same thing now. So this time we're pointed towards us. We're applying a force towards you. And so what's going to happen to that gyroscope? Try to figure out what's going to happen to it. I think I know what's going to happen to it. So they're pushing towards us, and it's actually moving down. So again, it doesn't make sense unless you really can stick to that right hand rule and figure out what's going on. And then if we were to do one more, so we're going to set that up. So now it's going to point away from us. And so I think I've got it figured out. As they push away from us, it's actually going to move up. And so again, what is the angular momentum of a system? It's the angular momentum of all the objects within that system. And so could you describe a model? Again, a gyroscope is a really good one. So you could analyze what happens when we add multiple objects to a system. I hope so, and I hope that was helpful.